Hello, welcome back. So let's continue with our AC sizing. In our last session, we sized this conference room. Now we are going to do the same for the rest of the spaces. Beginning with this classroom. You can choose to use the formula, the standard formula we used for this conference room, and do the calculation all over, or you can choose to use a rule of thumb, which is a kind of a shortcut. Since we have a pilot work, we can use the data, the value for this conference room, to make like a kind of an estimate to get the cooling load for these spaces. So now, using the rule of thumb, recall the floor area for this conference room is 37.13 meters squared, and the cooling load, the total cooling load we got was 62,279 BTU. So 66,279 BTU to cool 37.13 meters squared. So let's get the cooling load for 1 meter squared using this value. $66,279 BTU divided by 37.13 meters squared. So for each meter squared, 1 meter squared, we are going to require 1,785.05. Let's leave it as 1,785 BTU to cool 1 square meter of a space. Now, using this value, let's get the floor area of this classroom. So this rule of thumb will help us save a lot of time, though it has its own limitations. So the floor area for this classroom is 28.186. Let's leave it as 28.19 meters squared. So 1,785 BTU times 28.19 meters squared. We are going to have 50,319 BTU to cool this classroom. So I was talking of a limitation of the rule of thumb. You can see this classroom is being shielded by this conference room, meaning there is no direct sunlight on the west side of this classroom. For the south side is another side that gets a lot of heat gain from the sun. So, but again, the south side is being shielded. There is a kind of shading by this corridor. So that will bring about reduction in the cooling load of this classroom. So if we are to use the standard formula to do the calculation all over again, you'll find out that 50,319 BTU is way too much for this classroom, very exorbitant. So, and again, 50,319 BTU is not readily available in the market. We can only have 54,000 BTU for the outdoor unit. So, we are talking of 50,000 is much for this classroom. So you see, we cannot take 54,000. It will be extra much, right? So we can only come down to the lower BTU, which is 47,000. So let's use 47,000 BTU. Let's copy this. 47,000 BTU VRVS, because 47,000 BTU is a very big outdoor unit, so I don't think it comes as an ordinary outdoor. It comes in, I think it comes in a VRV, VRF. So for this, it's a classroom, not a conference room. Alright, so now we've gotten our outdoor unit to be 47,000 BTU. Let's get the capacity of each ceiling cassette. Let's divide 47, since we are proposing 2 rows of ceiling cassette for this classroom. So 47,000 divided by 2, we are going to have 23,500. So 23,500, we can't have this in the market. We can only have 24,000. And if we are to use 24,000 for the 2 ceiling cassette, their capacities combined will be way more than that of the outdoor unit of 47,000. So but what we can do is we can use 24,000 BTU for this, and then use 18,000 for this. So 42,000. So we have a deficit of 5,000, right? So this will work for the ceiling cassettes, and even the outdoor unit will be sufficient for the 2 ceiling cassettes, right? Because their capacities are much lower than the capacity of the outdoor unit. But the problem is we have a deficit of 5,000, which will be like a kind of a waste. There will be energy waste. There will be no economy in this setting. But we can choose to use an inverter motor outdoor unit, not an ordinary outdoor unit, an inverter outdoor unit, in order to minimize the energy wastage. So let's propose an inverter outdoor unit, inverter motor outdoor unit. Yes, so why we are choosing inverter is inverter will sense the cooling load needed for this space and operate the outdoor unit accordingly to deliver precisely the cooling load needed for this space, so as to minimize energy wastage. That is why we are choosing inverter. That is the special work of the inverter outdoor unit, in contrast to normal outdoor unit, which is not an inverter. So for this as well, because we are going to have a deficit of about 3,000, let's propose an inverter outdoor unit for this space as well, to take care of the energy wastage. So this arrangement is not centralized. Let me see how I can okay, I think it's manageable this way. Or you can choose to delete one, then use your array tool to do the centralization, just like we did for this, but we won't waste our time there. You already know what to do. Okay, so now this classroom is identical to this classroom and this as well, so we can just delete this. Then copy this. Oh, this has extended to this part, and this as well. This is falling freely to the ground. It's not going back to the outdoor unit, remember? Just to take it away from the window. All right, now we can copy this with reference to this door. Okay, so now let's do the same for this staff room. Let's get the floor area. Sorry. So the floor area for this staff room is 32.24 meters squared. .24 meters squared times 1,785 BTU, right? We are having 57,548 BTU. So for this, I think it's reasonable. Why? Because you can see it's similar to our conference room. The west side is not shielded, and this side, the south side, is also getting direct sunlight. There is no corridor shielding this south side. So, but the next capacity for this is 76. So just like that of the conference room. Okay, so we are just going to delete this, then copy this, sorry. Okay. All right, so we are using the same capacity with that of our conference room. Why? Because we don't have 57,000 BTU, so but the next higher capacity is 76,000. So we have no option than to use the same capacity as that of our conference room. Now for this space, let's get the floor area. So for this space we have 23.30. 23.30 times 1,785, 41,590. So 41,590, we don't have 41,000, but we have 47,000. But 47,000 is going to be way too much for this classroom. Therefore, we are going to take the lower BTU, which is 38,000. This is a classroom. And we are taking the lower, which is 38,000. Why? Because this classroom is being shielded by this staff room. No direct sunlight on the west side. This west side is being shielded by this corridor. So that's why we're taking 38,000 BTU. And it's also going to be a VRV. $38,000 BTU. For the inverter part, we don't know yet. Let's see. $38,000 divided by 2 row. 19,000. So we don't have 19,000. What we have is 18,000. So let's we don't have 36,000. If not, we could have just used 36,000 outdoor unit. So we have a deficit of 2,000. So we are also going to use an inverter to help us reduce the 2,000 wastage. And just copy this with reference to this door, place and place. All right, so in our next session we are going to get the capacity for this office and this office as well. Thank you for watching. See you in the next session.